In this video, we will show you how to use the Aventics Cylinder Finder based on an example application. We will explain the function of the tool in a few easy steps. Let's start by finding the tool on our website. On the Aventics homepage, you will find the menu item Engineering Tools. Under this menu item, you will find the Cylinder Finder, which you can easily open by clicking on it. You will only need 3 clear steps in the Cylinder Finder to find the cylinder that meets your requirements. Start with a description of the cylinder, then filter the settings until you reach the optimal solution. Before you begin with the first step, you have to select the system of measurement. You can choose between metric and imperial. The metric system is the most common measurement system in Europe. The imperial or Anglo-American measurement system is mainly used in the UK and the USA. In our example, we will stick with the default setting, the metric system. First, we will select the cylinder stroke. In our example, the stroke should be 150 mm. For the load to be moved, the forward and return strokes can be entered separately. This is how the displacement of an object can be shown, for example. The forward stroke is indicated by the orange animation, and in our example, it should be 30 kilograms. The return stroke is indicated by the blue animation, and in our example, it's only 2 kilograms. Afterwards, we can set the time for the forward and return strokes. In the default setting, the times for the forward and return strokes are the same, but you can change this manually. In our example, the time for the forward stroke is 1 second, and for the return stroke, it's half a second. The cycle rate is then automatically generated. You can't increase the cycle rate. If you try to enter a cycle rate larger than the one automatically generated, an error message will appear, showing the maximum permissible value for the cycle rate. However, it might sometimes be useful to manually enter a lower number of cycles. In our example, the cycle rate should be 1000 cycles per second. If necessary, we can now enter the angle of inclination. An info box can be found next to the input field. If you move over it with the mouse, the info box will show important and useful background information. In this case, the illustration explains the angle of inclination. As shown in the graphic, the angle of the cylinder motion can be freely adjusted between 0 degrees and 90 degrees. Enter 0 degrees for a horizontal motion and 90 degrees for a vertical motion. If, for example, an object needs to be moved vertically upwards, you must enter an angle of inclination of 90 degrees. In our example, however, the object should be moved horizontally, so we will leave the angle of inclination at 0. We will continue by clicking on the next step arrow. Now you must make an entry for the implementation. First, determine the type of cushioning. You can choose between external and internal cushioning. If you choose external cushioning, the cylinder will not have its own cushioning. This means there won't be any further cushioning calculation in the following steps. It also means that braking of the moving mass must be achieved through other measures in the machine or system. For example, through an industrial shock absorber or an elastomer bumper. Then you only have to enter the cushioning length. In most cases, however, cushioning is assumed by the cylinder. This is also true for our example. The next step is the selection of the cylinder guide. Here you can choose between external guiding and guided by the cylinder. Guided by the cylinder means that the cylinder carries the moving load. If you select this option, you then have to enter the length of the lever arms and the angle of rotation. The length of the lever arms has to be entered so that lateral torque can be included in the calculations. For example, the exact mounting position will be determined by indicating the angle of rotation. This will specify the angle of rotation around the x-axis and ultimately also the mounting position. To see examples of how to determine the lever arms and the angle of rotation in detail, you can move the mouse over the illustrations of the different cylinders. For external guiding, the moving mass is, for example, guided by a linear guide. The cylinder only needs to produce energy for the movement. It is not used for guiding. For our example, we choose external guiding. Now we're just missing the details for controlling the cylinder. All you need to do is provide the information for the tube length and the supply pressure. For the tube length, we'll use 3 meters in our example. Since we entered different mass loads in the implementation, there are also different supply pressures for the forward and return strokes. For the forward stroke, we're using a supply pressure of 6.3 bar. And for the return stroke, a supply pressure of only 4 bar. Now that all the relevant specifications for the cylinder have been entered, you can view the suitable cylinders. All you need to do is click on the Start Search button. The selection table now shows all the relevant and ready-to-use cylinders from all the series. In the weight and air consumption columns, the 3 best cylinders from each series are marked with an asterisk. Now you can use the filters to further reduce the selection of cylinders. If, for example, the cylinder is used in an explosive area, you can set the ATEX filter under the Environmental Requirements menu item. This will then only show cylinders that can be used in explosive areas. To show all the cylinders again, you just need to deselect the filter. You can also use multiple filters at the same time. For example, if the cylinder has to comply with the ISO 15552 standard and should also be equipped with a distance measuring sensor, you first need to apply the ISO 15552 filter under the Standardization menu item. You will then see the filtered section table, and you can add the distance measuring sensor filter under the Additional Functions menu item. The more filters you use, the closer you will be to finding the right cylinder. In the diameter, cushioning, and guide columns, you can check how close the shown cylinder is to your specifications. To do so, hover with the mouse over the data in the column. In an info window, you will see the cylinder's capacity utilization for the forward and return strokes. You can manually check which cylinder diameters of the series should not be considered. Click on the up or down arrows to expand the table to the next larger or smaller diameter in the series. The 2 top cylinders in the table have the diameter marked with a red dot. This means that their diameter does not meet your specified requirements. However, the 2 bottom cylinders are marked with a green dot. This means that they meet your requirements. The third possible marking can be seen in the guide column. Here, all the rows are marked with a gray dot. This means that the details of the guide are irrelevant, since the cylinder has an external guide. Criteria that are not important for the current selection are always marked in gray. For our example, we will take a closer look at cylinder 1 and cylinder 3. To check which cylinder matches our requirements better, you can view the information for both cylinders side by side. To do this, check the first and third checkboxes in the 7th column, and then click on the orange button in the header of the column. The 2 selected cylinders will be compared in a new tab. This way, you can quickly see the advantages and the exclusion criteria for the different cylinders. Here you can see the exclusion criterion for cylinder 1. It is eliminated since it exceeds the recommended maximum mass. The cylinder is automatically classified as unsuitable by the program. Now let's go back to the CylinderFinder. You can see more information about the selected cylinders from the PRA product series in our online catalog. To do this, click on PRA in the Product Series column. The catalog opens in a new tab. In the product information, you will see, for instance, an illustration of the cylinder and its pneumatic icon. In our example, we will choose the PRA cylinder with a diameter of 40 mm and pneumatic cushioning. You can also see the information on the cylinder in a PDF document and save the file. Simply click on the PDF icon in the Report column. The PDF file will open in a new tab and can then be saved. Before you can buy the cylinder, you first need to configure it. In our example, click on the Configure button in the Select column in the 4th row. In the new tab, you now need to select the suitable thread. You can either accept the already given diameter and stroke with the Continue with Defaults button, or enter new data by clicking the Continue button. For our example, we will choose the ISOThreads field and click on Continue with Defaults. You will be taken to an overview page showing the properties of the identified cylinder and the purchase price. Check once again whether the cylinder meets all the requirements, and then click on the shopping cart icon to buy the cylinder. And this brings us to the end of our tutorial. Try it out for yourself and see how easy it is to find the right cylinder.